Hey guys, it's Mr. Chefcheck here. Today's video is going to give you an introduction to a tool that we use often in math class called Algebra Tiles. One of the reasons we use this is that as mathematicians, we want to use appropriate tools strategically. That's one of our math practices. And so knowing when certain tools, like Algebra Tiles, can help you understand the math that we're working with, knowing when to use those and how to use those will be really helpful for you growing in your math understanding. So as you guys know, in math, we often use a variable to represent an unknown number. And some that we use commonly in pre-algebra and algebra are x and y's. And so those are going to be the two most common ones that you'll see us working with in class. So let's take a look at the algebra tiles we'll be working with. All right, so a couple of the tiles you'll notice are going to be blue. There's one that's dark blue, and this is called the unit tile. Sometimes we just call it the 1 tile. All right, it's got a value of 1. The one next to this here, the blue one, is the x tile. All right, and the one next to that is the x squared tile. All right, and now when you flip these over, you'll notice that the back side of the tiles are all red. And so the red side represents the opposite of each of those values, or sometimes we just say negative. So if this is our 1 tile, then the red side would be the value of -1. And if this is our x, then the other side is a negative x. And when we see the great big blue square, that's the x squared, the opposite of that would be a negative x squared. There are a few more tiles that we'll use occasionally, but maybe not quite as often. You'll also see a purple rectangle tile. This one we use to represent our y's, so just a different variable. And then when you have a tile that is a y by y, this is our y squared tile. And finally, every once in a while you might see one of our green tiles. Those are our x, y tiles. And the xy tile has a base of y and a height of x. And so since they get their name from their area, the area of this is x times y, so we call it the xy tile. You won't see that one all too often this year. And as with the blue tiles, when you flip these over, you'll see they are also all red, which stands for the opposite or a negative. All right, so let's see how algebra tiles can help us understand combining like terms and expressions. The value of the tiles that you see in front of you right now, we have an x and we have another x tile. So we could say this is x plus x. Well, what's another way of writing that? Well, you can add up the total tiles you have. You have 1x and 1x, which makes 2x. So the value of that expression is 2x. In math, we call that combining like terms. If I asked you to name this collection of tiles, could you do it? Well, let's look at each one as we go. We've got x plus x plus x. That's 3x. Plus I've got a negative x. And then I have an x squared. And then I have a -1. And then I'm just kind of counting up as I go here. I got 1, 2, 3 y's, and 1, 2, 3 units. Oh, we got a whole bunch here. Then we've got plus 3, oh, we have those 3, sorry, plus x squared, plus a y, and then plus a -y. Wow, that's a lot of tiles. So if we could find a way to simplify this expression and make it a little easier to work with, that would make things easier, wouldn't it? Well, the way that tiles can help us with that is we can go through and we can count up all of our like tiles, all the ones that we have that are the same. And so same size, same shape. And we can also simplify by making some zero pairs, which you're familiar with from our work with integer tiles. What that looks like with algebra tiles is we start grouping together are like terms. So I'm going to put the tiles that are the same shape by each other. And I'm also going to include ones even with the negatives nearby, just so that it helps me when I'm simplifying. All right, and now what I see here is we've got a couple zero pairs, right? If I have a -1 and a +1, that makes 0. I can eliminate that and make it a little simpler to work with. I also see over here I have an x and a -x. That makes a 0 pair. And I have a y and a -y that I can pull off my mat. And then I can just rearrange it so that I rewrite my expression by counting up the total number of tiles of each one. So I have an x squared and an x squared. That's 2x² tiles plus, I'm going to cross those out. Then I have an x and an x, so that's plus 2x. Cross those out. And then I've got 3 y's. And since they're purple, they're all positive. And then I've got 2 unit tiles left. That expression and that expression are equivalent, but this one up here is our simplified expression. And notice we cannot add x squareds to x's because, as you can see with the tiles, an x and an x squared are 2 different terms. Let's try simplifying another set of algebra tiles. All right, when you look at this, you see that there's a lot of different tiles here all laid out on the screen, and we want to start by grouping our like tiles together so that we can consolidate a little bit. So I'm going to just kind of rearrange by putting my x's together. Makes it a little simpler to see. I've got some y squareds, and then I've got some unit tiles, and a couple more x's, and then over here I've got those green, those xy's. All right, so when I'm looking at this, I can now start grouping to find some 0 pairs. So there's a 0, there's a 0, there's a 0, and there's a 0. So these tiles right here are all going to cancel out because every x has a -x that pairs with it. And then what I'm left with here with my x's is just this one right here. So that is an x. I'm going to cross that out, and now let's go to another shape. Let's go down to our unit tiles. We've got some 0 pairs here that are going to cancel out. If it lets me, there we go. We've got a 0 and another 0 by combining 2 positives and 2 negatives. And I see that I've got plus 3 unit tiles right here, and those are gone. When I'm looking at my xy tiles, I see I've got 2 of those and nothing cancels out. So I put 2xy. I don't need the dot in between, by the way. I can just write xy. I don't need the multiplication symbol. And then when I look down here, I have a y squared and a -y squared. And those are going to cancel out to 0. So I don't need to write anything there. I don't write 0y squared. That's not necessary. This right here is our simplified expression. On our final example here, I'd like you to try it yourself. You're going to pause the video, cancel out any 0 pairs you see, and record what's left, which would be your simplified expression. Then push play to see how you did. All right, on this one we started with -x plus 4x plus y plus a -y plus y plus x squared plus -3 and plus -2x squared. One thing I haven't mentioned yet that is important to hear is just that the order that you're listing these out does not matter since addition is commutative. So just keep that in mind. I may have started with my x's, but maybe you started with x squareds. That's perfectly fine. All right, let's see what this simplifies to. All right, so I'm going to start by finding some 0 pairs. An x and a -x, a y and a -y, an x squared and a -x squared. Those are all going to cancel out, and my simplified expression is what remains. So here I've got a -x squared. All right, and then I've got 1, 2, 3 x's, so plus 3x. And then I've got a plus y, or 1y, plus 1y is fine too. We generally don't write that though. And then I've got 3 negative tiles left, so I'm going to put plus -3. Now I could have also written -3. Either way would work. All right? So how did you do? Were you able to use those algebra tiles to simplify these expressions? If so, you're ready to move on. Thanks for watching.